Today, we're diving into one of the biggest game changers in AI right now, Retrieval Augmented Generation, or RAG. We're going to explore how we can give our AI an open book test on basically all the world's knowledge, and trust me, it changes everything.
So have you ever run into this? You've got this amazingly powerful AI, but you ask it about yesterday's news or maybe a recent update from your own company, and you get nothing. It just doesn't know. Why is that? Well, that's the exact problem we're going to solve today.
You're basically looking at a tale of two AIs here. Over on the left, you've got your standard large language model. Its knowledge is totally frozen in time, kind of like a brilliant professor who stopped reading books a year ago. It can't learn anything new, and honestly, sometimes it just makes stuff up. But on the right, that's an AI with a superpower. It's got a direct line to external, up-to-the-minute info, and, get this, it can actually show its work by citing its sources. The difference is, well, it's night and day. All right, here's our game plan. First, we'll dig into that core knowledge gap that all LLMs have. Then, we'll see how RAG is the perfect open book test solution. We're going to peek under the hood to see how it works, check out the tools you'd use to build it, and then we'll wrap it all up by talking about why this matters so much. Okay, first things first, the core problem. To really get why RAG is such a huge deal, you've got to understand the single biggest weakness of every standard language model out there. So here it is, the critical thing to remember. Every LLM, I don't care how powerful it is trained on a static, fixed snapshot of the past. Think about it. For GPT-4, for Llama 3, there is a hard cutoff date. Anything that happened after that moment is just a complete black hole for the model. It's like a brilliant historian who has zero clue what happened yesterday. And that, right there, leads us perfectly to the solution. You know, if the problem is a closed book, the solution is to give the AI an open one. So let's talk about RAG. So the official definition is this. Retrieval Augmented Generation is a technique that basically bolts an external knowledge base onto a language model. So before the LLM even tries to answer you, the RAG system first goes and retrieves relevant current information and feeds it to the model as context. And this is probably the best way to think about it, truly. Instead of trying to force an AI to memorize the entire internet and just hoping it gets all the little details right, we're just letting it look up the answer in real time. It's the difference between a super stressful closed book exam and a confident open book test. One is all about memory, the other is all about facts. So how does this magic trick actually happen? Let's pull back the curtain and break down the mechanics. It's actually a pretty elegant process. It really all comes down to this simple three-step dance. First is indexing. This is where we get our knowledge base ready, breaking all our documents into little chunks. Step 2 is retrieval. When you ask a question, the system instantly finds the most relevant chunks of info from that knowledge base. And finally, generation. And this is the magic part. Those chunks it found are handed to the LLM along with your original question, and the model is told, hey, generate an answer based only on what I just gave you. That simple little rule is what makes the answers so much more reliable. But wait, how does that retrieval step actually find the right stuff? I mean, how does a computer know that the phrase heart health is related to the word cardiology? Well, the secret is something called vector embeddings. Just think of it like this. Every piece of text, every concept, gets turned into a long list of numbers, like a coordinate in a giant map of meaning. Similar ideas get coordinates that are really close to each other. This lets the AI search for meaning, not just exact words. And you know, for anyone out there with a developer background, the folks at Hugging Face have the absolute perfect analogy. Think of a normal search as a strict SQL query looking for an exact keyword match. Vector search is more like a semantic where clause. You're not just querying for words, you are querying for meaning. It's a really profound shift in how we find information. Okay, so that's the theory, but how do you actually build this stuff in the real world? Let's pop open the RAG toolkit and look at the essential pieces you need for a production-level system. Now look, it is a fantastic learning exercise to code a simple RAG system from scratch. But any serious real-world application is going to rely on a stack of specialized tools that are designed to handle all these jobs efficiently and at a massive scale. So the foundation of your toolkit is a place to store all that knowledge, a vector database, and a fantastic open-source option is ChromaDB. It is built for one job, to store and instantly search through millions or even billions of those vector embeddings we talked about. This is the specialized digital library where your AI's open book is kept, all neatly organized and ready for a super fast lookup. All right, so your knowledge is all stored away neatly in a vector database. But how do you connect that to all your data sources on one end and then to your language model on the other? How do you manage that entire pipeline?
Well, that's where an end-to-end framework comes in, and Llama Index is just a phenomenal example. Think of it as the project manager for your whole RAG system. It has this huge library of data loaders to pull info from almost anywhere. PDFs, Notion, Slack, you name it. It handles all the indexing for you, and it acts as this universal connector between your data, your vector database, and your LLM, just making sure everything talks to each other perfectly. But let's take one step back for a second. A huge chunk of the world's most current information is on the web, right? And getting that data into a clean, usable format is a notoriously tricky problem. So how do you solve that first critical step of just getting the data in?
For this exact problem, you've got specialized tools like Firecrawl. It's an API built for just one purpose: turning messy, chaotic websites into clean, structured, LLM-ready Markdown. You can point it at a single web page or tell it to crawl an entire site. It handles all the messy business of scraping and cleaning, and it plugs right into frameworks like Llama Index, making it the perfect front door for any web-based RAG system. So we've seen the problem, we've seen the solution, we've looked at the mechanics, and we've checked out the tools. Let's bring it all home and talk about the big picture. Why is this such a massive deal for the future of AI? Well, RAG really represents a fundamental shift in how we think about AI. We're moving away from this model of an all-knowing but kind of forgetful oracle and moving towards a model of an expert researcher that can find and synthesize information on demand. This makes AI more knowledgeable, way more accurate, and ultimately a whole lot more trustworthy. And this is really the bottom line. With RAG, we can build AI that works with information that's completely up-to-date, or private, or super specialized. You can have an AI that answers questions about your company's internal documents. You get an AI that gives you answers based on real, verifiable sources it can actually cite. And maybe the most important thing of all, we can dramatically reduce the risk of the AI just making things up, what we call hallucinations, because every single answer is grounded in a real document that it just looked up. So, this leaves us with a really fascinating thought. We've gone from this world of a generic, one-size-fits-all AI brain to a world where we can give any AI a custom, reliable brain built from whatever knowledge we want. So the only real question left is, what are we going to build with that?